couple of days back, I wanted to make a sky trail picture with my DSLR. Now, for that, what's required is the camera needs to take a lot of pictures. The more the better, the more complete the sky trail is across the night. The problem being, when I first tried it, my battery ran out after 200 odd shots, so reasonably okay. The second one that I did, after I recharged the battery, put it back, went for around 800 shots, which is better, but still, it's not quite the full night that I wanted. So what I wanted to do was find a way that I can power my camera, and I've got a Canon 77D DSLR. So I wanted to find a way that I could power it somehow from the mains, right? Directly I cannot plug it in the mains, obviously, but from some sort of a power supply that I could plug into the mains and keep it powered at all times. I got obviously my original Canon batteries, but just spares. I got these, well, they're branded, but they're not Canon batteries. So the correct, the official Canon batteries that I used are these LPE17s, and this is just a cheap replacement for those. Okay, so what I want to do is, I've looked in the camera compartment where the battery goes in, and there seems to be a little flap which will allow for some wires to come out even when the battery compartment door is shut. It appears to be somewhere around here, right below this little notch that's on the battery. So I want to find a way that I can get these leads out through there, out of the camera, and then supply the power through some other source. But first things first, let's have a quick look at this battery, look at the specs. So it says the nominal is 7.4 volts, 1380 milliamp hours, or which works out, I would guess, to 10.2. It does not say anything about current ratings, which is a problem. But we'll cross that bridge when we come to it. So the original Canon batteries are quite costly. I don't want to ruin them, but these were quite cheap. So I'm going to open this up and see if there's a way that I can replace the innards. So let's get started. Before we take it completely apart, we shall have a quick look at what voltage it's actually supplying. I know the nominal says 7.4, 8.3, which means that's roughly around 2 lithium batteries worth. So let's have a quick look-see. I've disassembled this and made a few changes. So as the voltage indicated, there's 2 lithium cells, and as you can see, I've changed to a plastic spludger from a metal one, just because of lithium cells. So it looks like 2 of them, positive, negative, then on series onto the other one, negative goes in. So what it was working with was, there was a battery charging slash protection circuit based on the typical DW01 chip and others. What I've done is I've used my solder to get rid of all the components, because I'm not going to use a battery. I don't need a charging circuit. I don't need a discharge circuit. Part of the circuitry also provided some sort of compatibility with the camera. So the camera was fooled into thinking this was a Canon battery, and it did not protest. But we'll deal with that when we come to it. Yeah, it will protest, and yeah, but that's fine. So I've gotten rid of that. The two contacts that I'm interested in are the positive contact and the negative contact. These two are utilized by the camera to detect something, but again, they're not necessary. Well, that's what I feel, at least. We'll give this a quick test before we get any further. So to provide that test, what I've done is I've soldered on two reasonably thick wires, because I don't know the current consumption that we're talking about, and I had to chop off a little bit of the side. This just to allow for the wires to come out. The other thing I've done is I've just cut out a little notch, a little chip out of this corner, the corner opposite to the notch, so these leads could just come out of the camera, and I'm going to supply them directly from the power supply and see what type of current is being drawn. I have tested this in the camera, so I was able to thread the wires through here, pull them out through the little flap on the camera, and power them directly from this little power supply, which was set to 7.4, and I set the current limit to around 1.8 amps, just to give it a bit to play with. However, the most that I saw the camera consuming was during filming a video, like now, and even then it consumed around 650 to 700 milliamps. So what I want to do is a couple of things. I want to put some kind of a circuit that can supply up to 1 amp at 7.4 volts. That circuit in turn would be supplied, and I'm going to make a long cord out of this, but I think with USB. The reason is it's quite ubiquitous. USB charging points are littered all around my house, and also I'm thinking that I could start using the USB, the power banks, to power my camera. So to that end, I have gone through my drawer of things that I have and rummaged out a couple of things. So I found this and these sort of breakout circuits, little circuits that I had for DC to DC boost converters. It's boost because USB is around 5 volts and we need to provide out 7.4 volts, so we need a boost instead of a buck. There's two options. One is just the boost circuit, so this boost, and this has a boost with a battery charging and discharge protection circuit as well. So this is a bit too much. There is no lithium battery that I'm going to involve in the solution, so I'm going to go with this one. Now this one is a breakout board for the MT3608. It actually came with a multi-turn trimmer pot, something like this, which would control the voltage that will be generated at the output. So let's look at the data sheet for this MT3608 IC. So we can see that the input voltage can be between 2 and 24 volts. We know USB is 5 volts, well, around 5 volts. So it should suffice. Then we have a 4 amp switch current. Wow. Okay. We won't be going anywhere near it, and to be honest, I wouldn't trust something as puny as this with no heat sink or anything else, supplying or consuming even 5 volts at 4 amps, which is 20 watts. Yeah, no, okay, all right. But 1 watt, sorry, not 1 watt, 1 amp is perfectly fine, which we're looking at, up to 1 amp, that is. Right, output voltage 28 volts, that's perfectly fine. We need 7.4 volts, so that's fine. That is fine. And up to 97% efficiency. So we are looking at efficiency of above 89%, which is great. So we'd be transferring 7.4 volts into say 0.7 volts, which is around 5 watts, and it's a 90% efficiency. So we are talking about 10% wastage. So it's a 0.5 watt that the little chip over has to dissipate, which is perfectly fine. All right, so it's obviously variable voltage, so we will use this formula to figure out what resistances we put in. Now, as you can see, I've gone ahead and done that. I've put some fixed resistances there. As it turns out, this formula, the Vref, is 0.6 volts. R2 has a fixed component on this board. I don't know if you can see it over here. It's a tiny SMD resistor of 2.2K plus whatever is one side of the pot, and R1 is the other side of the pot. The pot that was supplied was a 100K pot. So I wanted to keep the current across the voltage divider similar to what was in the breakout board. So I chose R1 to be 100K, and for the output to be around 7.4 volts. I found out that R2 needed to be R2 was actually 9K. I put in a 6.8K in series with the 2.2 already on the board, and that should give me around that ballpark. So let's have a look. Let's test it outside first before we solder up all the connections. We are passing it 5 volts, and on the output side we are getting 7.4 volts, which if I'm not mistaken was around about 7.4. So we are coming around the nominal. Now what I want to do is I want to push this up slightly to around 5.5, well, a bit more. So we can see it's still holding steady at 7.4. Pull it down. Wow, okay, all right. So normally if it goes on this far, I guess the USB it's outside the USB standard, but it's still holding steady at 7.4. So that is great. Before I put everything in, I thought I will do a quick test rig. So what I've done is I have set this little power supply to 7.4 volts, which would be the output of the circuit, and I am going to use this load to ensure that I've got the same load as I've observed the camera to be consuming. Factor of 50%, which should be fine in terms of safety. So now this is calibrated to pull 900 milliamps at 7.4 volts. What we are seeing from here is it is drawing 1.5 amps, but if I'm not mistaken, sometimes I'm seeing a little flicker on the constant current, which means it is hitting the limit, which is at 2 amps. So to supply the camera the USB cord, which by the way, this is a old USB cord that I found. I've spliced it up and I've found out which are the leads that connect to the positive and negative, and this is what I'm going to use. But it needs to go into a USB socket which is supplying more than 2.4 amps, 2 amps, but I think there are the 2.4 amp sockets that are used for the Apple devices. 2.4 should be enough to supply this. I'm going to run this for a while and monitor how the board is doing temperature wise, because this is when I'm recording a video. If I'm powering it from USB, this will be what the load that this will be under. Well, 50% more, but it will be constant load that this will be under. So I have to ensure that it does not get heated. It has been running for a good 15 minutes. That's absolutely fine at 37 degrees. Everything else is chilled. So testing is a success. I will put all of this together in the casing and then come back to do a final test before we plug it in. So there we have it. I've put the circuit inside the enclosure, and I've put a bit of hot glue here just to act as a cable restraint, so reasonable tugs over here won't cause a problem. And then I've spliced the other end with the USB socket. So now time for a quick lost check. So there's 7.42 volts, and that's more or less steady, so we look to be good. So the battery replacement is in, and I plug the other end to my 2 amp supply. So moment of truth, let's switch it on, see what it says. Okay, it says battery communication error. Does it display the Canon logo? No, it doesn't. So yep, that's fine. Say yes, and voila, it's all working. It's all powered up. Let's go to a video mode, because this was the one that drew most current. And let's try to record some video. Yep, it's recording. So it's all good. All right, I'm going to nail this as a success.